Hi, welcome back to the session. Now we will discuss about backtracking technique. So this is related to fifth unit concept. Fifth unit first concept is backtracking. So here in this video we will discuss what is meant by backtracking and how backtracking technique will be working. What are various applications of backtracking and how those applications can be solved effective manner using backtracking technique? We will discuss in this class now. Okay. Now let us move to the next slide. Students, we are aware of that there are 5 algorithm design techniques. These are very most important algorithm design techniques, 5 algorithm design techniques, namely divide and conquer algorithm design technique, greedy algorithm design technique, dynamic programming algorithm design technique, backtracking algorithm design technique, and the last one is branch and bound algorithm design technique. Apart from these 5 algorithm design technique, we have 2 more algorithms: analysis, time complexity, and space complexity. So the entire design and analysis of algorithm subject will deals only those listed concepts only. Students, we have been completed time complexity and space complexity in first unit, and in second unit we have been completed how to solve various applications using design and conquer algorithms. So some of the sorting algorithms and some of the searching algorithms are best examples for divide and conquer algorithm design technique. The next one is greedy technique. In greedy technique, we use knapsack problem we can solve by using greedy technique, and also job sequencing with deadline problem also we can solve using greedy technique also. Single source shortest path problem, this problem also solved by using greedy technique, we already discussed in earlier classes. And next one is dynamic programming. It is also one of the famous or familiar algorithm design technique which can be used to solve single source shortest path problems and all path shortest path problems, 0 by 1 knapsack problem, traveling salesman problem, reliability design problems. These are various applications which we can be solved very easily by using the concept of dynamic programming. Students, we already discussed all the listed algorithms above. We already discussed in earlier lectures. Now in this video, we will focus on backtracking algorithm design technique. We will focus on backtracking algorithm design technique. So this is the fourth most algorithm design technique. What is meant by backtracking? Why backtracking is really required? What are various applications of backtracking? And those applications of backtracking can be solved in an effective manner by using the concept of backtracking algorithm design technique. We will discuss in this lecture. Okay. Now let us see how to solve backtracking technique. Okay. The topics are covered in backtracking technique are General method of backtracking technique. What is the general method we are processing and adopting for solving the applications in the backtracking technique that can be clearly described by using the method that is called as a general method of backtracking, which mainly focus on how really the animated backtracking technique can be done. We will discuss in this session. The next concept is 8-pin problem. So here there are two, we can solve 4-pin problem, 8-pin problem, and n-pin problem. These three problems we can solve in an efficient way by using the technique of backtracking. And another topic is sum of subset problem. Next important topic is graph coloring problem. Graph coloring problem. And last most one is Hamiltonian cycle problems. Hamiltonian cycle problems. Friends, in this video lecture, we will morely focus on how to solve n-pin problem, that is how to solve 4-pin problem, in how to solve 8-pin problem by using backtracking technique. We will discuss clearly in this video lecture. Okay. If you observe clearly, so this is the slide which represents the animation video of backtracking technique. How the backtracking will be working really, really it will be clearly described in this slide. Suppose if you want to perform the solution to the given problem, you have many ways to solve the problem. You have many ways to solve the problem. But now let us see how to solve the given problem by using backtracking technique. In this video, we will discuss now. So consider now if you want to solve the problem using backtracking technique. So here you can initially start the session. Initially we need to start the session. Once we need to start the session, we can go forward moving towards finding the result. Here there is a node. There is a node is we can connect reach to one node. That node is considered as a live node. L node. L stands for live node. That node is considered as a live node. That means that the node is still live. So here from starting point to we moved here, and again from here onwards we can move to this node. There is one more node is available here. We can move to this node further, and also here we are not getting any solution. We are not getting any solution. So then we can move to here. Then we can move to here. Now we reached the dead end. We need reach the dead end. Then there is no node we can go forward. So this is dead end. We can consider the dead end. Once you reach the dead end, then you do not have provision to move further. Then in this case, what we can do? Now we can simply applying the technique of backtracking. Now apply the technique of backtracking here. If you apply the technique of backtracking, so you can go back to the previous node. From the dead end node to, you can go back to the previous end. Here you are not getting any solution. That's why this node is to be treated as dead node, D node. D node stands for dead node. Dead node means there is no provision of extending the solutions of the node. There is no provision of extending the node. That's why I can consider as a dead node. So next one is I can move. Okay, I can forward to here. From dead node to I can move to here. Even if I can move to here, and again I can reach to the dead node. So once I can reach to the dead node, then applying once again backtracking. So now here I am applying backtracking. Once I can apply backtracking, go back to the previous node, and also solution not found. Why? Because this is considered as a dead node. Then again apply a backtracking technique here. Once you can apply backtracking technique, so back to the original problem. So move to the original problem, live node. Still it is live node. Now you reached the live node. So live node in the sense the node is still active. It is in the working condition. Once you reach the live node, and you can select if any way for going further to the next node. Here I have found one more node for going further. So I simply move on here. Next, one more node I have been found here. One more node I have been found here. So next, from this node to I will move to here. One more node is found, but solution not getting. Then again, moving forward to here, reach to the dead node. Once I can reach to the dead node, then again here I can apply backtracking technique. If I can apply backtracking technique, so when I reach to the dead node, so moving back to the this node. So then going forward, and again I can reach to the dead node. So once I reach the dead node, again apply backtracking technique. So when I apply backtracking technique, moving back, so finally I can reach to the dead node. Here I have not getting any solution. There is no provision of extending the solution to the given node. That's why I can consider this node also dead node. This is the dead node. So there are two dead nodes found here. Next, moving back to the live node. Again, I can move to the live node. Why? Because it is this node is to be considered as a live node. Once I can reach live node, the node is active. Then I can moving forward to the next upcoming node. So once I can reach to the upcoming node, one more node is found here. But here, so I can keep on moving to the next node, but there is no node is available here. I can reach the dead node. Once I can reach the dead node, there is no provision of moving forward. Then again, I can apply a backtracking technique here. So apply backtracking technique here. Then move to this node. This is called as a E node. This is called as a E node. E node is nothing but it is the node which can be placed before the success node, which can be placed before the success node. So once I can reach E node, then going forward here. So this is the destination. I have reached the destination, and now I can succeeded here. Once I can succeeded, so one node is to be generated. That node is to be considered as a successor node. This is the successor node. So initially I can start from the beginning node. So how to move from live node to successor node is clearly defined in this diagram. So meanwhile, we have visited many dead nodes, many live nodes, and many E nodes. Finally, move to the successor node. Okay. So students, once again, I can explain the animation diagram of backtracking, how it is really applied here. So if you want to start here, moving towards moving here, then once you reach the dead end, struck here. Once you struck here, then only you can apply backtracking technique. When you apply backtracking technique, where you struck, then you can go back to the dead node and keep on keep on applying backtracking technique till you reach the end of the node, that is called as a successor node. So by using why we need to apply backtracking technique is you can easily find the optimal solution in minimum number of steps. This is the one of the advantage of using backtracking technique. When you apply backtracking technique to the given example or given problem, you can find the solution to the given problem with the minimum number of steps. With the minimum number of steps, you can be able to find the solution. That's why, so it is considered as an efficient method for getting the solution. Okay. So students, way backtracking technique is applied in the real-time scenario, we will discuss. So some of the notable applications which are listed below. So these applications can be solved in an efficient way by using the technique that is backtracking technique. So the backtracking technique can be applied for solving n-queen problem. That means that here n in the sense n number of queens. So there is a possible way of solving 8-queen problem or possible way of solving 4-queen problems. So both problems can be solved by using backtracking. So if you want to solve 4-queen problem, there is a 4 by 4 chessboard, 4 rows and 4 columns, 4 rows and 4 columns. So like a chessboard, so this is a 4 by 4 chessboard. We can solve this 4 by 4 chessboard problem by using n-pin problem. So like that we can able to solve 8 by 8 chessboard. Consider there are 8 rows and 8 columns. So we can arrange the or place the queens on the 8 by 8 chessboard by satisfying the constraints. So in this way we can able to solve both 4-queen and 8-queen problems by using n-queen problem through backtracking technique. The next one is Hamiltonian cycle problem. Hamiltonian cycle problem is the problem. This problem can be solved in an efficient way by using backtracking technique. So we will solve the problem later on. Okay, we will discuss this later. Next, coloring the graph. So there are many possible ways we can color the graph. If the graph, even the graph can contain multiple nodes, we can color with the graph with minimum number of colors. How to solve that problem, graph coloring problem? So we can discuss in the next slide. So another name for solving graph coloring problem is M coloring problem. So graph coloring problem or M coloring problem, both are same. Here M in the sense number of colors, number of colors. Next important application is sum of subset problem. Sum of subset problems also solved by using a backtracking technique. So another important application which can be solved through backtracking technique is knapsack problem. So consider a knapsack. So you need to fill the bag with possible bags, but finally maximize the profit by satisfying the constraints. So that can be solved in an efficient way through backtracking technique. We will discuss this knapsack problem also in this next slide. Okay. So there are some efficient techniques, parsing techniques. So these parsing techniques are also solved by using backtracking techniques. And also verbal arithmetics, pseudocodes and crosswords and some of the puzzles. These can be solved in an efficient way by using the concept of backtracking. So students, there are around 7 very important applications are listed below. These applications can be solved by using the concept of backtracking technique. Now we will moving on the main concept of backtracking. What is backtracking? Why backtracking technique is really required? Why backtracking technique is required? We will clearly discuss in this session. Backtracking is, I already said that backtracking is an algorithm design technique. There are 5 algorithm design techniques. Among those 5, backtracking is also considered as one of the best algorithm design technique, which can be used to solve large instances of the problem. So even we can solve large instances of problems can be solved in an efficient way by using the concept of backtracking. Okay. So earlier, if you consider earlier, we have worked with greedy and dynamic. We have been worked with greedy technique and dynamic programming technique. So both greedy technique and dynamic programming technique, these two techniques will be works based on the concept of brute force algorithm design technique. It is called brute force approach. So both greedy and dynamic programming technique use the concept of brute force approach. So what is meant by brute force approach? That means that in both greedy and dynamic programming technique, the evaluation can be done all possible solutions. First, we need to find all possible solutions. First, we need to find all possible solutions. Among all possible solutions, I can select one solution that is the best solution. That best solution is to be considered as optimal solution. So, what is the methodology we can follow in greedy method? If you want to solve any greedy technique, first, you can select all possible solutions of the given problem. Once all possible solutions are to be generated, among those solutions, you can pick any one solution which can be performs better. That solution is called as a optimal solution. So the same technique or error can be used in dynamic and greedy technique, that is called as a brute force approach. But clearly observe that how backtracking is different when compared with greedy and dynamic, we will discuss now. So in backtracking technique, getting the same optimal solution. So we will get the same optimal solution with less number of steps. Very important. With less number of steps. Why backtracking is famous is you can solve the problem or you can provide the optimal solution or best solution with less number of steps. With less number of steps, by using backtracking technique, we can solve the problem in an efficient way. So friends, that's why we can use backtracking technique. The fundamental answer is why backtracking technique is required. The fundamental answer is if we apply backtracking technique to any given problem, we will get the same optimal solution with less number of steps, even if you compare it with greedy or dynamic programming. So that's why we can consider backtracking is an important algorithm design technique and a fast algorithm design technique. So it is working very efficiently than when you compare with brute force approach. Brute force approach. So every problem, if you want to solve any given problem, there are some constraints. There are some constraints. Constraints in the sense rules. So constraints in the sense rules. What are the rules? So sorry. So if you want to solve any problem, you have to follow some rules in the given problem. So backtracking technique use boundary functions. Backtracking technique is used boundary functions. So implicit constraints and explicit constraints. There are two types of rules here. One is implicit rule, another one is explicit rule. What are they? We will discuss. Okay. Rules in the sense, suppose what is the rule of knapsack problem? The rule of knapsack problem is the sum of weight is less than or equal to m. That means that the total weight of the items which you can place it on the knapsack is less than or equal to m, knapsack capacity. So total weight cannot be exceed the capacity of the knapsack. This is called as a rule. This is called as a rule or condition or constraint. Both are same. Constraints or condition or rule, all are same. So that means that there are some rules. If you want to solve backtracking technique, the rules can be depends on two constraints. The first one is implicit constraints and the second one is explicit constraints. There are some rules if you want to apply backtracking technique. Now let us see what is meant by implicit constraint and how explicit constraint will differ with the implicit constraint we will discuss here. Now here we will talk about a 4-queen problem. We will talk about 4-queen problem. That means that consider a chessboard. Chessboard size is 4 by 4. That means that 4 rows and 4 columns. Total 16 squares are to be generated. The total number of squares are generated. 16 squares are generated. Consider a 4-queen problem. There are 4 rows and 4 columns, and total number of squares are generated are 4 into 4, 16 squares are generated. So how many places are available? 16 places are available. This can be clearly represent explicit constraint. This is called as a explicit constraint. That means that in 4-queen problem, all 4 queens, queen 1, queen 2, queen 3, queen 4, where we need to place all 4 queens in a 4 by 4 chessboard, what are the possible ways? How many number of possible ways we can arrange or place our 4 queens on a 4 by 4 chessboard that can be clearly represents explicit constraints. Whereas implicit constraints means we have a provision for placing our 4 queens on a 4 by 4 chessboard in 16 possible ways, but the constraint is so while placing the queens on a 4 by 4 chessboard, we need to follow some conditions. What are the conditions? The conditions are no 2 queens, ఏ రెండు queen కూడా, no 2 queens cannot be placed on 4 by 4 chessboard in such a way that they cannot be in the same row, same column, same diagonal. So that means that you should not arrange the queens on a 4 by 4 chessboard in such a way that no 2 queens cannot be placed on a same row, same column or diagonal. రోస్ లో కూడా ఒకే రోలో ఉంచకూడదు, ఒకే కాలంలో ఉంచకూడదు, డయాగ్నల్ గా ఉంచకూడదు. సో అదర్ దాన్ సేమ్ రో, సేమ్ కాలం అండ్ డయాగ్నల్, దేర్ ఆర్ సమ్ పాసిబుల్ వేస్. సో యూ కెన్ ప్లేస్ ద క్వీన్స్ ఆన్ దోస్ available places that can be considered as a safe place. Otherwise, we can consider it as a dead place. Okay. So these are some of the constraints, implicit and explicit constraints of 4-queen problem. Next topic is now we will discuss about how to solve 4-queen problem using backtracking. The question is how to solve 4-queen problem by using backtracking techniques. This is the question. Now we can solve the problem, given problem, by using backtracking technique in an efficient way. So I will tell you the step-by-step procedure to solve the problem in a graphical mode. You be patient and listen carefully. This is very important and very easy. Just follow my lecture, what I am clearly explaining, right? Hope you all are following. Okay, right. Now start the solution of the given problem, how to solve the problem. So first of all, the problem is n-queen problem. So n queens means here n in the sense number of queens. Number of queens. There are n number of queens. So here the n value may be anyone. The n value may be anyone from 1 to 1. N is initially start from 1 and keep on incrementing the value of n till n. That means that n value vary from 1 to n. So if it is a 1 by 1, that is called as a 1 by 1 chessboard. Here the first one represents row and the second one represents column. If it is a 4 by 4, I can consider this is a 4 by 4 chessboard. That means that 4 rows and 4 columns. And if it is a 8 by 8 chessboard, 8 rows and 8 columns. 8 rows and 8 columns. 8 rows and 8 columns. So in this way, we can consider n queen problem. Here in this video, we will focus on how to solve 4 queen problem and how to solve 8 queen problem by using n queen problem technique we will discuss. Okay. So here, before starting here, now initially you can consider the chessboard. You can consider a chessboard. The chessboard size is n by n. N number of rows and n number of columns. Initially, you can consider the chessboard. Once you can consider the chessboard, let there are how many queens? N number of queens. These n number of queens are to be placed on which chessboard? N by n chessboard. Number of rows and number of columns chessboard in such a way that what are the constraints here? No two queens cannot be placed on the same row. So you cannot place any two queens on the same row. You cannot place any two queens on the same column, and you cannot place any two queens on diagonal. On diagonal, that means that same row, same column, and diagonal. You cannot able to place same row, not possible. Same column, not possible. Same diagonal also not possible. So other than this, you can place the queens in efficient way, whatever you require. Okay. Now I can solve the problem by using the example. Okay. Now let us consider a chessboard. Now here I have been taken a chessboard. So what is the size of the chessboard? The size of the chessboard is 4 by 4 chessboard. Now I am considering the chessboard of size 4 by 4. That means that here 4 rows, 1, 2, 3, 4. These are considered as rows, and these are considered as rows. Sorry, these are considered as rows. So here, how many rows? 4 rows. And here, how many columns? 4 columns. Now consider queen 1, first queen. This is queen 2, second queen. Queen 3, third queen. And queen 4. Total, we will consider 4 queens and consider take a 4 by 4 chessboard. So here the main objective of 4 by 4 chessboard is you can arrange all 4 queens in the chessboard in such a way that by satisfying the condition that no two queens cannot be placed. No two queens are placed in the same row, same column, same diagonal. That means that you cannot be placed two queens in the same row, same column, and same diagonal. Same row, same column, and same diagonal. Suppose if I have been placed first queen here, assume that if I have been placed the first queen here, so the condition is you cannot be placed the next queue in the same row. This is the same row. I cannot able to place queen in the same row. I cannot place here. Same column also. This is the same column. I cannot place the next queen in any one of the others. And diagonal. This is the diagonal. So these are the diagonal part. Cannot able to place the next queen in a diagonal way also. That means that same row, same column, and the same diagonal. Same diagonal. Diagonal. So the first queen I have been placed. Now I have the provision to place, next I have the provision to place the second queen in any possible way. So here I cannot be placed second queen. Here also I cannot be placed second queen. Why I cannot place second queen here? Same column. I cannot place second queen here. Diagonal comes. So that's why I can place second queen here. I can place second queen here. This. And once I can place second queen here, and again apply the same concept, same constraint, same row, same column, and diagonal also. So these are also diagonal. So here, next I cannot be placed queen 3. There is no provision of placing queen 3. Why? Because this is the row 3. In row 3, I cannot be able to place next queen. So here, what will happen? Simply I can struck here. I can simply struck here. When I can simply struck here, what will happen? That is called as a dead node. I can reach the dead node. Once I can reach the dead node, what I shall do? I simply apply the concept of backtracking technique. Simply apply the concept of backtracking technique. When I can apply backtracking technique, next go back. So apply backtracking technique one by one. That means that go back, move back. So go back. So like this one, we can be apply backtracking technique. So we can apply the backtracking technique, and we need to change the position of the queue by satisfying the constraints, placing the queens in such a way that no two queens cannot be placed in the same row and same concept. Now we will see clearly in an animated way how to solve the problem in very efficient manner. Okay. So now move on to the next slide. Friends, this is the first slide for solving 4 by 4 chessboard. Now here, place the first queen. This is the first queen. Queen number is Q1. Now I have been placed the first queen in first row, first column. 1, 1. First row, first column, I have been placed. First row, first column, I have been placed Q1. Once I can place Q1, there is no provision of placing another queue by satisfying the column, same column. This is the same column. I cannot be placed in the next column. Here I cannot be placed here. Okay. Here also I cannot be placed also. So this is row. Same row also I cannot be placed. I cannot be placed same row also. Okay. So this is the first step. Okay. Next one is once the first queen is placed here, next is place the second queen. So first queen is placed here. So I cannot be placed the next queen in these rows. I cannot be able to place first queen. Here I cannot be placed. Here I cannot be placed. Here also I cannot be placed. Okay. So this is same row. In the same row I cannot be placed. Same column also not possible to place. Same column. And this is the diagonal also not possible. Then what is the possible way I can place Q2? So this already Q1 was placed already. Where I can place Q2? Next my question is where to place Q2? Where I can place Q2? So I can place Q2 here. There is a provision I can place Q2 here. Okay. So why? Because there is a safe mode. I can place the Q2 here. Okay. So now let us move on of placing next queue. Okay. Next, I have been placed next queue. So here I have been placed already. First queen I have been placed here. Second queen I have been placed here. So when I can place the first queen, this first row, first column, all first rows, and first columns, and all diagonals also not possible. When I can place second queen here, second column and second row and diagonal of second also not possible. This is the diagonal of Q2. Diagonals Q2 also not possible. Here the problem is I have been already placed Q1 and Q2. These two queens I have been already placed in a 4 by 4 chessboard. I have been placed successfully. Two queens are placed successfully. Now I am planning to place third queen. So if when I try to place the third queen on a 4 by 4 chessboard, what will happen? There is no space of placing third queen in a third row. There is no way, not possible. There is no way of placing, not possible. What is not possible? Placing of Q3 not possible. Q3 placing of not possible. Why? Because all are these are not considered as safe modes. These are not considered as safe mode. Okay. So once I can reach here, the next step is so there is no provision of placing Q3 in third row. In third row. Why? Because all are considered as a these are considered as a unsafe modes. Unsafe modes. Next, what I can do, I simply apply the concept of backtracking. There is no provision of placing Q3, Queen 3 on a 4 by 4 chessboard here. So then I can simply apply backtracking technique. Simply apply backtracking technique. When I can apply backtracking technique, what shall I do? Simply apply the backtracking technique, then go back, moving to the second row. Moving to the second row. So, but here, what can I do? You have the provision of placing the next queen Q3 here. If I can place the next queen Q3, what will happen? This is also not considered as a safe mode. This is also not considered as a safe mode. So then what can I do? What can I do? I cannot place Q3 here. I cannot place Q3 here. Q3 I cannot place here. Why? Because this is the not the possible way. So I already placed Q1 here. I already placed Q2 here. But Q3 I cannot place. I cannot place here. The solution is I have the provision. I have the provision for moving Q2 from here to here. So moving from Q2 from here to here. So now we will see. So just moving the Q2 here. When I can move Q2 from here to here, when I can place the Q2 here, then redraw the same. Redraw the same. Next Q2. So here, this is the first queen, Q1. Second queen was moved from here to here. It was moved from here to here. The place was changed. When I can apply backtracking technique, I can go back and moving the position of the Q2 from here to here. So you keep on changing the value. Okay. So Q2 already placed. Next, I can try to place Q3. So now I am planning to place Q3 here. When I am planning to place Q3 here, so in third row I cannot be placed Q3 here. Why? Because same row, same row. I can place Q3 here. This is the safe mode to place Q3. Why? Because it is not attacking any Q, same row, same column, and same diagonal. So Q3 also placed, Q1 placed, Q2 placed, Q3 also placed. Next, what will happen? Where I can place Q4. Next, the question is where I can place Q4. So there is no possible way of placing Q4. Why? Because Here I cannot be placed with Q4. Here also I cannot be placed with Q4. Here I cannot be placed with Q4. Here also I cannot be placed with Q4. So there is no provision of placing Q4. Then what I can do? Simply I can struck here. I can struck here. So unable to place fourth queen, so struck here. Once I can struck here, I can consider this is the dead end. Once I can reach the dead end, then apply backtracking technique. Then apply backtracking technique. So unable to place Q4 in fourth row, so struck here, then apply backtracking technique here. Once I can apply backtracking technique here, then go back to the third row. So third row also not possible. These are full. So third row also not possible to place. Already one queen was placed. So fourth queen I cannot be placed here. So I need to do some rearrangement of placing the queens once again. Then once again I can apply backtracking technique. When I can apply backtracking technique once again, move back to the previous place, that is row 2. Then I can apply the concept of backtracking once again. There is no way of placing another queue here by satisfying the constraint. Again, applying backtracking technique. Here, I can keep on applying backtracking technique by selecting the way where I can place the first queen. So next is when I can apply backtracking technique, three stages in a stage-wise manner. When I can apply backtracking technique, so I can reach to the first row, first column. So I cannot be able to get the solution. I cannot able to get the solution when I can begin the solutions by placing the first queen from first row, first column. So hence I can change the place of first queen from here to here. I am moving the queen from here to here. Then I can apply the same concept to check whether all the remaining queens are able to place or not. So, okay, first queen I am placing here. Okay, now let us see what will happen if I can move or place the first queen here. If I can place first queen, let us see what will happen. So this is the first queen I have been placed. So when I can place the first queen, next I can place second queen. So if I want to place the second queen, I cannot be placed the second queen here. I cannot be placed the second queen here. Here also not possible. Next possible way is safe mode is here. Next place second queen. Next I can place second queen. Possible way is this is the possible way. So I cannot able to place in these three. Next I can able to place second queen here. So when the second queen is placed successfully, next check whether the possible way of placing the third queen. So where I can place third queen. So here there is a possible way of placing third queen. So next third queen also placed. Next fourth queen. Where I can place fourth queen. So there is a safe mode. If I can place fourth queen here, no other queen is attacking by satisfying the constraints of no two queens can be placed on the same row, same column, and same diagonal. So this is the fourth queen I can place it. So now check here, clearly verify that if I can place the first one here, I have been placed Q1. This is Q1, Q2 was placed here, Q3 was placed here, and the fourth queen was placed here. Now I have been successfully placed all four queens in a 4x4 chessboard. In a 4x4 chessboard, I can be placed all four queens in a successful way. Once all 4x4 queens are placed on a 4x4 chessboard, then you get the solution. So once you will get the solution, then you can start the process of backtracking technique. So here, so this is the first row and first column. So if you apply first row, first column, and same row, same column, and diagonal by satisfying the condition, you can place it here. So the solution is where I can place a Q1. Q1 was placed in second, Q2 was placed in fourth place, and Q3 was placed in first place, and Q4 was placed in third place. Q4 was placed in. So this is solution 1. This is solution 1. S1 is solution 1. So you can place the queens in such a way that, okay. So here, now let us see the time complexity of 4 queen problem. How to find the time complexity of 4 queen problem? So before discussing about the time complexity of 4 queen problem, the size of the key chessboard is 4 by 4. The size of the chessboard is 4 by 4, 4 rows and 4 columns. 4 rows and 4 columns. So the possible number of ways I can place first queen is, the possible number of ways for placing the first queen is 4. So I can place here, 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 here. There are 4 possible number of ways I can place queen 1. So that's why the possible way is 4 ways I can place here. Once I can place the first queen, it will occupy in any one of the row. It will occupy any one of the square. Next, I have the possibility of placing the second queen is 4 minus 1, that is 3. One second queen also successfully placed. I can place the third queen in 2 possible ways. Once 3 queens are placed on 4 by 4 chessboard, I have only one place. Definitely, I need to place the queen, leftover queen in that place only. So that means that 4 into 3 into 2 into 1. That means that it is going on decreasing. That is considered as order of n. N number of times it is decreasing or increasing. So the total time complexity of 4 queen problem is order of n factorial. Order of n factorial is the time complexity of the 4 queen problem. Okay. So students, here you can solve the 4 queen problem by using backtracking technique, but here in a graphical way you can represent the backtracking technique or 4 queen problem by generating an algorithm, by generating one structure that is called as a tree, one data structure. So here we are using one data structure. So for placing the n queen problem in in backtracking, that is called as a state space tree. We can consider as a state space tree. Here tree is the data structure. Okay. What is mean by state space tree? The tree constructed to implement backtracking with the choice for the components is called as a state space tree. So the state space tree we will draw with an example. Now we will see. Okay. Now here, consider here, there is a 4 queen problem. If you consider there are 4 queen problem, if you consider 4 by 4 chessboard. So this is the initial node. This is the initial root node. So in 4 by 4 chessboard, how many ways we can place? So there are 4 ways. 1, 2, 3, 4. All 4 ways we can able to place the queen. So in this way, the first way, second way, third way, and fourth way of placing the queens. Okay. So next is next is yeah. So now the first queen was placed. Once the first queen was placed, so what are the leftover queens? Queen 2, queen 3, queen 4. There are 4 queens you need to arrange on a 4 by 4 chessboard. If first queen you can place it, what are the leftover? 2, 3, 4 are leftover. Draw it initially. Next, moving on to the second root node. Here, the root node is second. So, what are you need to visit what nodes? You need to visit node 1, node 3, and node 4. Already, node 2 is the base node. So, the leftover nodes you need to visit is 1, 3, 4. Next, you can move to the root node 3. So, here, root node 3. here, if you consider this is the root node, so Q3 is already placed, and again you have the choice of placing how many ways you can arrange the queen. You can arrange Q1 here, Q2 here, Q4 here. So you can place the remaining Q in a first order, second order, or fourth order. So this is the fourth one. You can place the queen in first order, second order, third order. Any way you can place it. So this is the second stage. Next stage is, so already you have been visited 1 and 2. 1 is the root node and this is the live node. So next you can you have the provision of leftover is 1, 2. Next one is 3 and 4. 3 and 4. So total 4 queens are to be placed. Total 4 queens are to be placed. So that means that, so how to place R4 queens is, you have the provision of placing R4 queens. From 1 and 2 are placed, 3 are placed, and 4 are placed. This is one way. Another way is, first place third queen, next place second queen, next place fourth queen. This is another way. Another way is, already first queen was placed, next place fourth queen, second queen, third queen you can place. So in this way, you can keep on arranging all the queens. This is the third stage. This is the third stage. Next one is fourth stage. This is the last stage. Here, the diagram clearly represents all possible combinations of placing 4 by 4 chessboard. All 4 queens are to be placed in a 4 by 4 chessboard. So how many ways we can place all 4 by 4? There are 4 into 4, 16. So now let us see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there are 24 ways you can able to place all 4 by 4 queens in a 4 by 4 chessboard. Now let us see, we will get the tree. All possible combinations are to be generated. Among those possible combinations, by satisfying the constraint, how many ways you can arrange the queens, that is the important one. So here you can place the queens in order. So how many ways we will see here in the next slide. Here, students, you will get two solutions in 4 by 4 chessboard. This is solution 1 and this is solution 2. If you observe solution 1, so here 2, 4, 1, 3. This is represents the position of queens. This will represents the position of queens. 3, 1, 4, 2 will represents the position of queens. We can arrange. So here, if you observe clearly, both solutions will satisfy 4 queen problem. So there are two results we will get. This is result 1 and result 2. So in this way we can arrange the queens. So now we will see 2, 4, 1, 3. In state space tree we will draw clearly 2, 4, 1, 3. So 2, next is 2, 2, 4, 2, 4. Next one is 1, 2, 4, 1. Next is 3, 2, 4, 1, 3. So here 2, 4, 1, 3. This is one result. This is one result. Next result is 3, 1, 4, 2. 3, 3, 1, 4, 3, 1, 4, 2. So this is another result. Okay, represents 3, 1, 4, 2. So among those 24 solutions, only 2 solutions will yield the result correctly. These are the 2 solutions which can be satisfies the constraints of the problem. So the 4 by 4 chessboard, we will get 2 solutions. This is solution 1, this is solution 2. So these considered as a solutions. Remaining all are considered as a possible ways of arranging. possible ways of moving or placing the queens on a 4x4 chessboard. So this structure, this tree structure is considered as a state space tree. This is the state space tree. So by using state space tree, we can animate the position of the queen exactly where to place on the 4x4 chessboard. Okay. So students, this is the final result of placing the 4x4 queens on a 4x4 chessboard. Okay. If you consider 5x5 chessboard, this is the solution for placing 5 queens. This is the solution for placing 5 queens. By satisfy the constraints, same row cannot be placed. The first queen, this is the first queen. When you can place the first queen, same row cannot be placed. So same column also cannot be placed. And this is the diagonal. Same diagonal also cannot be placed. So first queen I can be placed successfully. Next, observe the second queen. If I can place second queen, second row cannot be placed. Second column cannot be, this column also cannot be placed. The diagonal part of this also cannot be placed. It is also satisfying placing. Next, this queen, take this queen. The row cannot be placed. In the same row cannot be placed. Same column also cannot be placed. Diagonal also cannot be placed. Okay. So it is also satisfy the condition. Next leftover is this one. So same row cannot be placed. No queen is placed. Same row. Same column also cannot be placed. And we can able to place this queen also. So we can be placed all 5 queens successfully in such a way that by satisfying the condition, no 2 queens can be placed in the same row, same column, and diagonal. So these there are two results. These are the two solutions for 4x4 chessboard. You can arrange or place 4 queens on a 4x4 chessboard by satisfying the condition. No 2 queens cannot be placed on the same row, same column. Okay. So this is solution 1. This is solution 2. So we will discuss 8-pin problem in the next session. Okay. Students, hope you all understood very well. Okay. So thank you. Thank you, madam.